So you will see in the homework for tonight that some of the trig functions are going to be straight up from your unit circle, like pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, something like that. And then some of them are going to be applications of that unit circle. So my advice to you was this yesterday, and I said I would do it again today. When you are figuring out an angle that is not on your natural unit circle, you basically have two choices. Well, three. One I wouldn't advise, but you could have three. One option, which I would say is my least favorite, is convert your angle to degrees. Find the coterminal by adding or subtracting 360 until you get to something that's on your unit circle. Eventually you could get there, okay? It has to be. So if it was like 750, right? So whatever that is in radians, you would convert it by multiplying by pi over 180. You'd get 750. You'd subtract 360 twice. You'd end up with 30 degrees, and 30 degrees is on your unit circle. That's an option. That, to me, takes the longest because you have got the conversion and the coterminal, okay? Option 2 is keep it in radians and find the coterminal by adding and subtracting 2 pi. If it's small, maybe that's not so bad. If it's a huge number and you have to keep adding or keep subtracting 2 pi multiple times, or if it's really negative and you have to keep adding 2 pi multiple times, that's when you're going to waste your time on that one, okay? But that one's not awful. So if it was like negative 15 pi over 2, I'd have to add 2 pi, which I'd change my denominator. So this would be 4 pi over 2. Add that, I'd get negative 11 pi over 2. Still not on my unit circle. Add again, 4 pi over 2. I get negative 8 pi over, wait, did I do it right? No. Negative 7 pi over 2. Still not on my unit circle. I'd have to add it again. Negative 3 pi over 2, which you might be able to find at the top, right? Or find it on the bottom and fold it in half. Or add it again. And I'd get pi over 2. Yep.
Why didn't you just add any even number?
You can add any even number. Yeah. So that's the third way I would say, and that's the one I would recommend, is convert it to a mixed number. The even whole numbers would be on the right. The odd whole numbers are going to be on the left. And then the top and the bottom are the halfway point. So if my whole number is, let's say I take that 15 pi over 2. I'm going to make it negative. I'm positive first, and then we'll do it negative. 15 over 2 is what in mixed number? 7 and 1/2. So 7 tells you to start on the left because it's odd. So 7 pi would be right here. My coordinate point would be negative 1 over 2. I mean negative 1, 0. The halfway mark says to go to the halfway mark. If it was less than a half, I would stay in quadrant 3. If it was bigger than a half, I would go to quadrant 4, and it would end on either your over 3, your over 4, or your over 6. It has to. So because it's a half, I'd know I'd go to this angle. My coordinate point there is 0, negative 1, and then I can answer all of my trig functions from there. Yep, so if it was 6.5 pi, I would start here, and I would go to the halfway point, which is on the top.
So if it wasn't a half, you would just, like, say it was, like, 3/4.
So let's say I get 5 and 3/4. So you want to do 3/4 pi.
So you would go to the odd.
I go odd, and then is 3/4 less than a half or bigger than a half?
Bigger.
Bigger, so I go past the halfway.
And then you just go to the one that's over 4.
Yep. And if you know you're over 4, you already know that coordinate point. I know it from the moment I see this problem. All I got to do is figure out is it positive or negative, and that's why I need to know what quadrant it lies in.
Would it ever be, like, over 5?
No, not without a calculator. Okay. If you got that, you'd have to have a calculator to find it. So every single angle that you find without a calculator is going to be a whole number, because you could find those. It's going to be an over 2, an over 3, an over 4, or an over 6. Those are your only options. Yep. All right, so now let's say it was negative. So let's go back to, let's say it was negative 15 pi. And let's make it a different one. Let's make it 15 pi. Well, that will reduce. So let's make it 11 No, 11 pi over 3, okay? I'm going to do the same thing I did. I'm going to make it a mixed number. So 11 over 3 becomes what? Negative 3 and 2/3. The 3 part says go to the left, so I'm over here. That would be my 3, right? And now it's negative. So instead of moving in this direction, which would be my positive angle, I go the other way. So I go this way, right? If it was less than a half, I'd stop at the first over 3 in the second quadrant. 2/3 is bigger than a half, so I go to the other over 3, and that puts it in the first quadrant. And then whatever, I got 1/2 and root 3 over 2. They're both positive because it's first quadrant. So if it's positive, you're going counterclockwise like a normal angle. If it's negative, you're going clockwise. Yep.
How do you know, like, if you have to go even farther?
So it's all, that's your whole number. Whatever your whole number is. So if your whole number is bigger than 2 pi, is what, you mean initially?
Like,
Or do you mean once you get it into mixed number?
once you get into mixed numbers.
So if it's a whole number, you're going to have to go, you should never have to go more than once around if you use this trick. Because the whole number, like instead of making this negative 3 where I would start here and I would go negative 1, negative 2, negative 3, and then 2/3, I use the even odd whole number trick. So it eliminates the need to go coterminal. Does that make sense? Okay. So again, you have those 3 options. I will almost always pick the third. If you need help with the other 2, I can certainly do them. But in my opinion, third option is the most efficient. So as long as you know all your over 3s, all your over 4s, all your over 6s, your over 2, and the whole numbers, you can figure out the values. Then comes the, in what quadrant is it? And then that determines your sign. Use what? So you're going to fill that out, which means you'll get to use it here, which means these questions will probably not come directly from your unit circle, right? That's the catch. Because you get back that unit circle, they're probably not going to be a 7 pi over 6 or an 11 pi over 6. It's going to be more like 13 pi over 6, where you have to do what we just did. Yep. All right, so we did these yesterday with the calculator, okay? And we left off here. So we did reference angles with degrees, right? In the last, that's what you were tested on. In this quadrant, theta prime is theta. In this quadrant, we did 180 minus theta. In this quadrant, we did 180 plus theta. No, sorry, theta minus 180. Theta minus 180. And in this quadrant, we did 360 minus theta. That was to find reference angle in degrees. To find them with radians, you have 2 choices. One is if it has pi in it. So if my angle is 2 pi over 3, or 7 pi over 3, or 8 pi over 3, something like that, then the reference angle on those special angles is always the bottom. Anything over 3, the reference angle is pi over 3. Anything, once simplified, I should say, over 4, your reference angle is pi over 4. And anything over 6, your reference angle is pi over 6. And that's why what we just did works. I could tell you 23 pi over 4, and you know that that reference angle is pi over 4, which means the coordinate point is root 2 over 2, and root 2 over 2, you just got to figure out your positive negative signs. Anything else, so you might get a pi over 5 or a pi over 7 or a pi over 10 mixed in there, then the reference angle in radians for the first quadrant, it is what it is. So if I had 2 pi over 7, which is less than a half pi, then 2 pi over 7 is the reference angle. If it's bigger than a half but smaller than 1, so it's in the second quadrant, what's the equivalent of 180 degrees in radians? Pi. We would do pi minus theta here. So if I got 3 pi over 5, it's bigger than a half but smaller than 1, right? Because 3 is bigger than half of 5 but smaller than 5. So I would find the reference angle by doing pi minus 3 pi over 5, 5 pi over 5 minus 3 pi over 5, and I'd get 2 pi over 5. Most of the ones in radians are your special angles, so they're easier. They are whatever the bottom is, okay? But that can happen. In the third quadrant, we would do 180 or theta minus 180, so we would do theta minus pi. God bless you. And in the fourth quadrant, we would do the equivalent of 360, which is what? 2 pi minus theta. This is to find the reference angle. So remember the reference angle had to be 90 or less than it. That's like saying it has to be pi over 2 or less than it.
Why does it say 3?
Well, we're going to get to that. So now what if it's not in terms of pi? What if pi is not in there? We substitute the value of pi. So if I told you to find the reference angle, which is what the next question say, find the reference angle of 0.75623, and there's no pi in there. Then I would just convert pi to be 3.14. So in the first quadrant, I still leave it the way that it is. The reference angle is the way that it is. In the second quadrant, instead of using pi, I would use 3.14, and then I'd subtract theta from it. In the third quadrant, and this should be the other way around, theta prime minus 3.14. And in the fourth quadrant, 2 times 3.14 would be 6.28, and then I'd subtract the angle from it. So if it's in degrees, you use your original ones. If it gives you pi on your radian, then you use what we did in purple in the first time. If it gives it to you in decimal form without the pi and it's not in degrees, then you use this last one, which is what this is. Yeah. All right, so this says use a calculator to find this. That S theta means like the reference angle. On the interval of 0 to 2 pi, round your answers to the nearest hundredth. Okay, so this time, this is telling you that the cosine of S is 0.9685. What are we looking for with these? The answer is the angle, right? So we're going to first look for the reference angle and then find the actual angle. So we did these with degrees. These are the ones that give you 2 answers and you got to find out what the second answer is. Now we're going to do them with radians. So the first thing I'm going to do is I'm going to do cosine -1 of 0.9685. This is looking for the angle. And be careful because these need to be in radians. So now we're switching to radians, so your mode wants to be, you should be in radians. So second cosine 0.9685. And I get that theta or S is 0.2516, which is going to bump this up, 0.252. Now that's the angle in the first quadrant, right? But where is cosine positive? The first quadrant and the fourth quadrant. So I've got to find the angle using what we did the last time. So when we're finding the angle, and this is the reverse of what we just did. So if you're looking for the reference angle, you want to follow what we just did. When we're working backwards, so we just found the reference angle and we want to find the actual angle. In the first quadrant, you leave it alone. In the second quadrant, whatever you get for your reference angle, you're going to subtract from 3.14. In the third quadrant, you're going to add it to 3.14. And in the fourth quadrant, you're going to subtract it from 6.28. So we're reversing that reference angle process.
I thought the third one was theta minus.
That's if you're finding the angle given a reference. So if you're finding the reference angle. So this time, we get the reference angle, and we want to know all the angles. So this is my reference angle, right? So if you're given an angle and it says find your reference angle, you start with an angle. You're finding a reference angle. That's what we did the last time. These, we're starting with our trig functions. We're finding the angle, and then there's a second one somewhere. We've got to find the second one. So that's why it's different. This is different than what we just did. This is not finding the reference angle. This is finding the actual angle. Usually it's just, excuse me, the second one, but when it's negative, we find both this way. Okay, so now I'm going to take this, because this would be, cosine we said it would be in the fourth quadrant, we're going to do 6.28 minus 0.252. So the other option here is 6.028. And then like before when we did these are easy to check. I would find the cosine of each of these. And I would end up with the question. The rounding's going to be off because we just rounded it, but that's what you're going to do.
How did you notice that that's in the fourth quadrant?
How did I know what? Because it's cosine, and cosine is positive. So you look at the original sign. So where